Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Simon Phipps joins me. We're going to be talking about Kong and Kuma, great ways to make your applications scale through a large network. You're not going to want to miss this, so stay tuned. FLOSS Weekly is brought to you from LastPass Studios. Securing every access point in your company doesn't have to be a challenge. LastPass unifies access and authentication to make securing your employees simple and secure. Check out lastpass.com/twit to learn more.
Podcasts you love.
From people you trust.
This is Twit.
This is FLOSS Weekly with Randal Schwartz and Simon Phipps. Episode 562, recorded January 15th, 2020. Kong. This episode of FLOSS Weekly is brought to you by LastPass. LastPass is a personal password manager and identity solution for businesses that helps secure everywhere you work and live. One password gets you in, and LastPass will take care of the rest. Visit lastpass.com/twit to learn more. And by Melissa. Bad data happens to good companies. That's why 10,000 businesses count on Melissa for clean, reliable address data. Get started today with 25,000 records cleaned for free. That's a $75 value at melissa.com/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, little projects, projects you may be using every day and not aware of it, projects you may want to play with right after this show. I think today might be one of those. Joining me once again is my lovely and talented co-host, Simon Phipps. Simon, welcome back to the show.
Why, thank you so much, Randal. It's great to be back. New year, new show. What more could we ask?
I know. The first show I've done of the new year, because I was out last week sick. I am coughing badly still, so I'm going to try to make sure I hit the mute switch often enough. But you may hear an occasional cough as I continue through this. And also, I was up coughing last night, most of the night, so I don't have a lot of sleep behind me. But that's life. That's just the way it works. I am in my home in Beaverton, Oregon, which is rare, and it's supposed to have snow flurries today. So we're getting that sort of weather these days. So that ought to be fun. And Simon, you're, I think, in Southampton?
I am once again in beautiful Southampton. We had Storm Brendan came through last night. And so I didn't get much sleep either, because we had 70-mile-per-hour winds going past the house and things blowing down and the cat going crazy and all sorts of other stuff.
Eek. Well, we're talking about a couple things today, so that'll be fun. We're going to have... where's my list there? We're going to have Marco Palladino on in a few minutes talking about a couple of projects, actually. He's going to talk about Kong, which we've actually had a show on, it's got to be like 2 or 3 years ago. And also his new thing, Kuma, which will be fun to talk about both of those. And Kong is a next-generation API and service lifecycle management platform. Boy, that's a lot of buzzwords. So if you're playing buzzword bingo, you probably just filled out the first row. It's designed for modern architectures, including microservices. Oh, that's always a buzzword. And then we got Kuma coming up, which is also related to that, which is sort of a service mesh thing, which, again, I don't know much about either of these, but that's why we have the guest on to be able to talk about both of these. And like I said, I'm trying not to cough into the mic. I'm trying to hit the little button here quick enough to be able to do that. Simon, what do you know about these so far?
Very little, really. When I was a kid, we used to use object marshalling. And then along came service buses that all the younger people were using. And now the people who use service buses are old people, and they all want to use service meshes. So it's all the same ideas redigested twice, as far as I'm concerned. So I'm looking forward to finding out exactly how this is pushing the state of the art forward and giving Red Hat a run for their money, because this is at the heart of their architectural dreams as well, I believe.
Yeah, and I'm just going to say up front, this is going to be a slightly shorter show than normal because we started late. I was having trouble with Skype, or maybe it was Skype or something, maybe audio hijack, and it was rebooting my system over and over again. So hopefully my system does not reboot during the next 25, 30 minutes. But this might be a shorter show than you're used to on Floss Weekly. But just letting you know that ahead of time. Maybe we can stretch a little bit at the end. I don't know. We'll figure something out. We have hard outs at the end of this time slot, so it's going to be a little tricky. But if we don't have anything else to talk about before bringing on the guests, let's go ahead and talk about the fact that this episode of Floss Weekly is brought to you by LastPass. 17.8 million people and over 61,000 businesses trust LastPass. Shouldn't you? LastPass is an award-winning security solution that helps individuals and businesses navigate their online lives easily and securely. You can choose between the personal plans, free, premium, or families, or the business plans, teams, enterprise, MFA, or identity. Go to lastpass.com/twit, where you can get into the nitty-gritty of each plan to find out what will work best for you. So what makes LastPass so great? It generates strong passwords. Share passwords or notes within LastPass to employees or family members. And LastPass for Business offers flexible password management, single sign-on, and multi-factor authentication options. You can go on any device, anywhere. It holds personal or corporate credit cards, pictures of passports, and other important documents that need to be secured. And it now offers passwordless login options for employees, which increases security and productivity. And LastPass Security is ahead of its time. They engage trusted, world-class, third-party security firms to conduct routine audits and testing of their services and infrastructure. Their detailed review of their controls and processes is a gold standard for confirming the security and reliability. Sensitive data is encrypted at the device level with AES 256 before syncing with TLS to protect from man-in-the-middle attacks. Twit uses LastPass Enterprise, and I also use LastPass since the beginning of when it was offered. I basically signed up for it right away as soon as I saw that it was available. You'll need LastPass for you and your business with their amazing features that will improve security around your company and make life easier for your users. Visit lastpass.com/twit to find out how they can help you. That's lastpass.com/TWIT. And we appreciate LastPass for their support of Floss Weekly. So let's go ahead and bring on Marco. Marco, welcome to the show.
Hey, thank you so much.
And where are you speaking to us from?
I am in Sonoma.
Oh, cool. Sonoma. I'll wave in your general direction. That's kind of over here somewhere. There we go.
Not far from San Francisco.
Yeah, and there's my coughing. I didn't hit the mute switch. Sorry, guys. So we had Kong on the show before. We haven't had anything about Kuma yet because that's fairly recent. What problem are you solving if I'm reaching for Kong or Kuma?
Kong is our first open source product that we have released in 2015. And Kong is a API gateway. It allows developers and organizations to secure, protect, enable API consumption within either internal developers as well as external developers, right? So it's your typical API gateway that you will need whenever you have an API that somebody else or something else has to consume. Now, Kuma and Service Mesh in general is a natural extension to the kinds of problems that we're fixing with Kong. Kuma is a service mesh that's universal. Like Kong, it can run anywhere. It's built on top of Envoy, which is this very popular data plane proxy that's being used by not just Kuma, but other service meshes as well. It's a very solid technology with a very nice API to integrate with. That's why it's so popular. It was built by Lyft. And with Kuma, we're enabling connectivity among any service within the organization to be safe and reliable. Among those services, we're going to be having APIs. So APIs are not going to be the only services we're running. We could be running databases. We could be running Redis. We could be running any sort of thing, including APIs that we want to expose and APIs that we want to enable via governance policies that allow to either onboard the developer, to explore the documentation, to secure that communication from a north-south standpoint. And for those services, we're going to be putting Kong Gateway in front of it. But when we look at the final architecture on how an API gateway and the service mesh can be working together, we're looking at service mesh as these underlying network overlay that makes sure the communication among all our services is working. And then for those services that we want to enable to other teams or other developers, then for those teams, for those services, we could use a gateway like Kong gateway. But from a service mesh standpoint, a gateway is a service among the other services that we're running.
So explain to me in simple terms, what is a service mesh? I mean, I understand, the basic concept of, I want to put up a port that's listening at a particular address, and I want to talk to it with some other server, or some other client. How is a service mesh different from that?
Every time we build an application, the application most likely does not live in a vacuum, under a rock. It needs to communicate to other services. If anything, It needs to communicate to a database. It needs to communicate to other components that we might be developing that are dependencies to the main application. And if we transition to microservices, we're just going to create more and more of those network dependencies. There are network dependencies because in order to be consuming these services, we have to go over the network. If we want to consume a database, we have to make a network request from the app to the database.
Sure.
And this is the main problem that we're going to be having. Microservices do not introduce the network. They just make that network dependency much bigger because we have much more back and forth across many more services. So if anything, they make an existing problem that we have, even in monolithic applications, it makes that problem much bigger because now we have a bigger scale. And so every time we go over a network, well, there are a few things that we have to take care of. The network, as we all know, is by default unsecure. It's by default unreliable.
Right.
The request can fail. There might be latency. And the more network requests we make, the harder it is for us to understand and determine where problems could and will occur, right? And so how do we trace all the requests that our application is making across the network in order to be able to identify problems in a faster way whenever they happen? So what service mesh really is a way to implement this connectivity among different services over a network. Service mesh is not something new. Developers and organizations have been doing that since forever. Every developer today that wants to build an app that talks to a database, well, they have to think about what happens if that request fails. Every developer is doing that today. It's not something new. It's a different way to be implementing these sort of features that make the network reliable, make the network secure, that up until service mesh, we were building ourselves. So the developer who was building the application, they were building the app, right, the business logic, and then they were building all these set of things that made the application work well. But with service mesh, we're fixing the same problem in a different way. We're telling developers, if you're building an application or if you're building a service, if you're building anything that needs to make a request to something else over a network, do not build that network management within your application like you've been doing until now. Don't do that. Leverage an out-of-process proxy that's going to be running alongside your service or application, and that proxy will take care of the network. All you need to do is making requests out there. Don't worry about securing them, protecting them, retrying them, or tracing them or logging them. All of those things are taken care of by this out-of-process proxy that you don't have to worry about. So effectively, the same way we are, delegating, for example, we don't want to manage our own virtual machines. We want to be leveraging public cloud vendors because we don't want to manage our own data center. Likewise, we don't want to be managing our own network management. We want to delegate that to something else. And that something else is this proxy, which is called the data plane proxy because it runs over the data path of our requests, right? So every time there is a request coming out or a request coming in, this proxy is in between that. The more services we... Yeah.
So this is about discovery, load balancing, failover? Is it all of those?
It's about security, routing, load balancing, like you said, so that we can implement things like canary releases or do blue-green deployments. It's about tracing, logging, mutual TLS. It's about identity, right? And it's about creating reliable and safe applications in untrusted environments. And in a way, Service Mesh, we're working with the open source community, of course, but we also work with some enterprise, our enterprise customers. And for example, in the financial industry, it's a big deal. It's a big deal because before Service Mesh, the teams were implementing identity and encryption and security of the transport layer. And guess what? Each one of these teams was doing it in a different way because they were building it themselves. And there's fragmentation when you do that. Instead, by telling the teams to stop doing that by themselves and leverage something else, like a Service Mesh, now they can achieve consistency, and therefore they can be more compliant when it comes to sharing information within their systems.
So once again, you talked earlier about the relationship between Kong and Kuma. Can you explain that a little more detail now? Sure.
So we're making requests across our architecture, and we want those requests to work. We want them to be traceable and to be loggable. Kuma, Service Mesh. There is going to be a subset of those requests that are going to be requests that are coming from other products, other business units, other mobile application, or any other client that's external to the data center, right? It's north-south traffic that needs to be governed and needs to be managed. When it comes to that, when it comes to offering a service via an API as if it was a product, that's where API management comes in. So there are complementary feature sets and complementary use cases that can work together to provide the full life cycle, building services, connecting them together, and that's Service Mesh, and then offering these services to external teams, developers, or products, and that's API management.
Interesting. Okay. So what do I have to do to drop this into my architecture? I mean, how do I have to restructure, rather than just listen with the socket on an address? There's probably something more I have to do here, right?
The idea here is that we're going to be having a data plane proxy alongside every replica of every service that we're running. So for example, let's say that we have 10 different services. One of them can be our backend application. Another one can be our database. Another one can be Elasticsearch, right? For each deployment of these services, we're going to be having a proxy that runs on the same underlying machine so that the proxy and the service, they can always communicate on localhost. They don't go outside in the network. They stay on the same underlying virtual machine. Once we have deployed our applications, our services, and then we have deployed a proxy in each one of them, we want to be able to monitor and manage and observe what these proxies are doing from a management standpoint. Every time we change a configuration, we don't want to restart every single instance of our proxy. We want that to be dynamically configurable. So we need to have a source of truth where we can push all the policies changes and configurations on our end, and then push that configuration to the data plane proxy so that dynamically we can reconfigure them without having to restart them every time. And that central point that saves all the policies that we write and that we want to push to the data plane proxy, that thing is called a control plane. So we're going to be having a data plane proxy alongside every service, and then regardless on how many proxies we have running around, we're going to be having a control plane, one of them, that's going to be connecting to all of these proxies in order to, A, push configurations to the proxies every time we want to change something, and B, being able to collect statistic information and analytics information from those proxies in the first place. So the control plane, it's called control plane because it allows us to control those proxies. And it's not on the data path of our requests. The data plane is with the data plane proxy. So Kuma, to answer your original question, Kuma is a control plane. So every time we want to deploy Service Mesh because we want to build more reliable architectures, we need to have a control plane. And so a control plane that either we can build or a control plane that we can use from the open source community. And Kuma is an open source control plane that anybody can download for free. They can run within their systems to connect to as many Envoy proxies they have across the architecture.
Okay, so now I have to ask you some questions about business model in all of this, in that case, Marco. So I've been having a look at the code. It's all Apache licensed, I see. And I noticed that you've got the code up on GitHub, and you have a reasonably buzzy community up there. So what sort of open source is this? Is this open source where you have an enterprise version that you monetize? Or is this open source where there are many people going to be using this code for their commercial activities and you have a different commercial angle that goes around it? What sort of open source is this?
It's the very similar open source to Kong Gateway. So we have released our core technology open source so that anybody can use it and download it for free. There's going to be a subset of that adoption, which is going to be requiring from us. It's either enterprise support or enterprise features. Some of those features we ship through Kong Enterprise, which is our enterprise product. Kong Inc., the company, only sells one product, and that's Kong Enterprise. And so unless developers require either access to those extra features, premium features if you wish, or they require our support, or they want to build a relationship with us, unless they need that, they can keep using the open source version for free. And quite frankly, this is really where we come from. That open source adoption is in turn providing a benefit to them as well as providing a benefit to Kuma, because the more users and the more developers and the more deployments of Kuma, the better Kuma becomes, the core of Kuma becomes, not just for them, but as an extension to that, to our enterprise customers as well. And really, enterprise is how we support and find the resources to keep then open sourcing more and more software to the broader community.
So are there other developers in your community who have the same business model as you, or are you the only entity with this business model in your community?
If you look at companies like Elastic, if you look at companies like Confluent, Kafka, if you look at companies like DataStax, the makers of the guys that are behind Cassandra Enterprise, it's a very similar model, right? So it's something that has been working very well in the open source community for a simple reason. It's working very well in an open source community because it keeps the expectations, right? And as long as those expectations are clear and that trust between the community and the organization that's behind the project, it's not broken, then it's a very successful model to keep sponsoring open source projects and at the same time capture enterprise mindshare and adoption in order to be able to support those open source projects in the first place. Open source, it's a great way to get software out there. It's a great way to give that value, but it's not free to build, right? And so the enterprise line of business supports our open source explorations.
And is that going to keep on working for you? Because companies like Elastic and Redis have been saying that having an amoral predator like Amazon Web Services in the market is preventing them from continuing with that style of business.
This is a very interesting topic right now that's happening in the open source circle. I think that fundamentally, if the market is commoditizing something, it means that that's a clear indication that we need to go higher in the stack and provide more value or better value into something else. With that said, cloud vendors, sometimes they do adopt open source technologies, and there would be nothing bad about that, if only for the fact that sometimes they do not contribute back. So a company like Kong or a company like Elastic or a company like Confluent, would sell an enterprise product, but then we would be using the learnings from the enterprise product to create even more open source features or to make the product better. Whereas sometimes cloud vendors, they do take these open source projects, by the way, in accordance to the license. So they're not doing anything wrong. They're doing something that's perhaps one might argue morally wrong, but it's not legally wrong, right? So the licenses allow that. So they're taking those projects, and there would be nothing bad about that, if only for the fact that they're not really contributing back with the same speed and pace and value that the original maintainer would do. So they take open source, they commoditize it, they productize it, but then the open source community gets nothing back. And that is perhaps the only problem I have, because if otherwise they would do that, I mean, that's the essence of open source, and as long as the license allows to do what they're doing, I see nothing wrong with that. So
do you have
makes
that
it more
problem?
challenging. Yeah.
Because I look at Redis and Elastic, and I notice that MongoDB, and I notice they're all changing their licenses in order to protect themselves from the situation that you describe, and yet they're still highly profitable and don't actually seem to have a problem. So are you in that path? Are you going to change your license?
That's not something that we're not even internally brainstorming to do. We think that things happen in a very organic way. As long as we, as core maintainers of the project, are able to push enough value into the product, there is no reason why anybody would want to go into something else. We're a product company at the end of the day, right? So I strongly believe into making good products. And the thing about cloud vendors is that they build features that are very wide when it comes to the adoption. So the cloud vendor is trying to offer a service that can work for 80% of the customers they have on their cloud, and that means everybody, right? And it works if you're trying to scratch the surface and if you're trying to implement something very basic. As soon as you try to get deeper and deeper into building something that's more specific, well, now all of a sudden, the cloud vendor struggles with that because they don't have the bandwidth to go as deep into the product as the original core maintainer would do, because they have not just one service, they have 180 services or 200 services they have to maintain. So usually what we're seeing in the market is the cloud vendor does something like this. It's good enough to get up and running with, and then eventually the enterprise organization will hit a roadblock that requires them to go back to the original core maintainer, which in my opinion makes sense, right? The core maintainer has a bigger incentive to make their users and their customers successful on their own specific product, as opposed to a cloud vendor that has to spread that attention to hundreds of different services.
Well, we have a couple questions from the chat room, but before we do that, I do have an important message, because this episode of Floss Weekly is brought to you by the leader in address verification, Melissa. Every address is covered from Adelaide, Australia to Zipacada, Colombia, and everywhere in between. We all know there's nothing good about bad data. It costs money, hurts sales, and decreases your customer satisfaction. If bad addresses, duplicate records, and bouncing emails are hurting your business, isn't it time to come clean with Melissa? Delta Faucet, Z1 Motorsports, and Car2Go use Melissa. You should too. Delta Faucet was able to improve their call center processes with global address auto-completion. Melissa was able to reduce the fraudulent e-commerce transactions for Z1 Motorsports by 90%. Melissa provides a full spectrum of data quality protection for your customer data. Verify postal addresses, mobile numbers, and email addresses. Update the addresses of customers that have moved and eliminate duplicate records. Gain additional customer insight into your data with Melissa's analytics. Easily build address verification and customer data validation into your custom application using Melissa's APIs, CRM cloud connectors, and e-commerce plugins, or upload your customer file for a quick data cleanse. Melissa is serious about securely managing your data. They continually undergo independent security audits to reinforce their commitment to data security, privacy, and compliance requirements. SOC 2, HIPAA, and GDPR compliant. Mailers spend about $20 billion annually in undeliverable mail. Don't lose customers or cash. Make every address count. Bad data happens to good companies. That's why 10,000 organizations worldwide trust Melissa to get their customer data clean and accurate. Get started today with 25,000 records cleaned for free. That's a $75 value at melissa.com/twit. That's melissa.com/TWIT, or call 1-800-MELISSA to find out more. And we thank Melissa for their support of Floss Weekly. So I'm curious now, how do I is this mesh creating just an empty pipeline? Does it have to be particularly structured data that goes through this pipe that I'm sending through the pipe?
It can be any. You mean for service mesh?
Yeah.
Any TCP traffic.
Okay, so if I'm, say, just sending HTTP requests, for example, I could deliver this through that.
Correct.
Cool. And so how did the mesh project get started? And you said it's derived from something. It sits on top of something, Envoy or whatever. How did that get started?
Envoy.
Okay.
Envoy, it's a very, when we build software, we're trying not to reinvent the wheel and trying not to build everything from scratch. If there are already projects out there that we can leverage that are doing this job very well. And so
Sure.
for Kong, if you recall, for Kong, we leveraged Nginx as one of our core technologies. And for Kuma is a Golang project that's leveraging Envoy for the data plane proxy technology. And it's a great technology to use and to build. Kuma, therefore, allows to deploy and maintain and allows to configure Envoy proxies that we have running across our infrastructure. One of the biggest challenges with service mesh, it's not even, first of all, I don't like the word service mesh because it wrongly implies that we need service mesh only when we have a mesh of hundreds or thousands of services. But that's not true. The benefits of service mesh can be leveraged even if we have a monolith application consuming a database, right? Even if you have as long as you have one request going over the network, as soon as we do that, either we build that network management ourselves or we leverage something else. So the fact that microservices make this even more required because the scale of requests we're making is much bigger, that doesn't mean that if we have a smaller app, we cannot benefit from something like service mesh. And Envoy really has a very nice and clean API that allows a product like Kuma to be able to hook into that API, data plane API, to configure then the proxy, at runtime. One of the things that we looked at when building Kuma, we first of all needed a service mesh ourselves. And like many other companies out there, all the service meshes that you find online are primarily focused on Kubernetes. And Kubernetes, it's a great technology and a great platform, but chances are that not all of your workloads are going to be running on top of Kubernetes. We're going to be having workloads running on virtual machines, workloads running on all sorts of things. Therefore, we built something that we needed ourselves. We built a platform agnostic service mesh that can run as well as on Kubernetes, as well as on virtual machines and other environments. So we can deliver the value that service mesh provides, not just for new greenfield Kubernetes deployments, but most importantly, for the existing applications that chances are processing most of our business today, and they're running not on Kubernetes, but they're running on virtual machines. And if anything, implementing a service mesh on virtual machines, because we anticipate moving to Kubernetes, it's just a better way to implement Kubernetes in the first place, because service mesh reduces the risk for that transformation. So instead of implementing, of transitioning to containers, transitioning everything, and then implementing service mesh as the last step, we can have all the benefits of service mesh in preparation to that transformation. Therefore, we want to have security before we transition to Kubernetes. We want to have tracing and logging and all of that before we make this big transition, such as we can lower the risk and be more successful with Kubernetes in the first place. The reason why,
sorry, go ahead.
Just one last thing. The reason why Kuma, the reason why other service meshes are not running on other platforms, but they're primarily focused on Kubernetes, is because Kubernetes does a lot of things for free. So it's easier to build a service mesh on Kubernetes than it is to build it for other platforms. With Kuma, we put a significant effort into building an abstraction layer that can work on top of Kubernetes as well as on virtual machines. It doesn't come out for free. We made very important architectural decisions that unlocked this opportunity for Kuma.
And what's your competition out there? I mean, so there are other projects that are doing roughly what you're trying to do, right? How do you compare to those?
We built Kuma thanks to the feedback of our 200 enterprise customers that are today finding value with Kong. And we built a very pragmatic service mesh that's oriented not towards future ambitional architectures only, but first and foremost can be used today, right? And so we're working with teams that before Kuma, they could not use service mesh because they could not deploy anything on virtual machines, or perhaps other service meshes are quite complex to use and to deploy. They have many moving parts, whereas Kuma is one component that can be deployed, and across any architecture, but it's one thing. So when you want to scale Kuma, you don't have to wrap your head around 5 different dependencies. Kuma itself, it's one component. You can scale it horizontally, and therefore it's easier to deploy and it's easier to use. And simplicity really is, if you ask me what's the secret sauce, simplicity is the secret sauce. The same simplicity that Kong Gateway brought into API management, which is the reason why Kong over the years got a big open source adoption. Well, that same simplicity we want to deliver into service mesh with Kuma. And so simplicity, agnosticity, being lightweight, being easy to wrap your head around Kuma certainly are things that were missing in the market before. And that's why we built Kuma in the first place.
And is Kuma configurable with something like a JSON or a YAML file?
Kuma can be configured via, if running on Kubernetes, we can configure Kuma with CRDs, so in a very Kubernetes native way.
Sure.
If we're not running on Kubernetes, we can use a RESTful API that can be consumed by CI/CD products or can be consumed by client-side clients, command line clients in order to configure in the system. And we can use JSON, we can use YAML, we can use, like I said, Kubernetes CRDs, we can use APIs. And there is also a GUI that comes out of the box with Kuma. So it's very simple to use Kuma with the best technology, the best technology for the job, basically.
Right. Yeah. I'm really always encouraging people who are trying to choose between YAML and JSON to use YAML, because YAML is a superset of JSON. So if you want to write a single line of code in a YAML file that looks like a JSON structure, you can do that. But most people don't know that about YAML. So it's like, hopefully everybody longs onto that. We're almost out of time, and I apologize for that. This is going to be a short show just because we had technical issues of getting my laptop from stopping to reboot while we were trying to get set up. Is there anything we didn't ask that you want to make sure our audience is aware of before we let you go?
Not really. I think we covered the basics of what service mesh is. I wanted to demystify service mesh a little bit.
Sure.
It's not something new. It's a better way of doing things that we've already been doing in the past. Right. So chances are we're already doing connectivity management, and we're probably doing it in a poor way because developers, they don't care about that. They want to build the products. They don't want to deal with the network.
Right.
And so I suggest people who were thinking to look into service mesh, but perhaps they ran away from service mesh because it seems like this very complex topic that only applies to microservice-oriented architectures, perhaps to give it another try and and see how service mesh can help existing applications, including monolithic ones.
Right. And my audience would kill me if I didn't ask the following 2 questions, which is, what is your favorite text editor?
VI.
Not Emacs. All right. Anyway, it'll work. And what's your favorite scripting language when you have to write a script?
That's a very good question. I try to use Python for most things.
Okay.
So I guess that's your answer, Python. But Python. I'm very proficient in the Bash scripting as well.
Okay. Cool. Hey, Marco, I wish I had more time. I'm sorry that we started late, but this is the show as it is, and we'll have to take it at that. And thank you for coming on the show and talking to us about about Kuma and also sort of refreshing our knowledge about Kong. I appreciate that.
Thank you, Randal.
Great. That was Marco Palladino talking to us about those 2 projects. What do you think there, Simon?
I think it's all very well executed. It would have been good if we had had the extra time because there was plenty to dig into. It turns out that they're involved in Linux Foundation in the Open APIs initiative over there, and so they're using Linux Foundation to control their competition through standardization. Jeff Bezos is one of their investors, and so they appear to be inoculated against the evils of AWS, unlike the other companies that we were mentioning there. So they appear to have some very sound business basics, and that's allowing them to do open source as the proper way, by releasing the code as Apache code that anyone can use, rather than trying to bolt it down to protect their enterprise version. And so it would have been good to dig into those things. But the fact that all of those things exist mean that this looks very solid. I would guess they are a prime acquisition target for someone like IBM Red Hat or for one of their competitors. Very interesting product. Incredibly complex stuff, though. Ever since service mesh was a phrase that I first heard, it's been almost impossible to understand what's going on if you're not actually building one. It's like the rest of cloud to my head. I hear all this stuff about how AWS or other cloud services work, and it's impossible to get to the bottom of. But it's really quite impressive stuff, and I would be interested in speaking to them again on another occasion when we had the audio worked out beforehand.
Yeah, well, I mean, the fact that the service mesh is basically providing discoverability, failover, and just data passing, the data plane stuff is really interesting. So I would have liked to talk more about that, but again, technical problems notwithstanding, it's been an issue. Anyway, let's talk about who's coming up. So next week we've got the Apprentice program, which is talking about getting more women into tech, which is going to be fun. So we got a couple of people coming on to talk about that. We have Open Mainframe, which is, amazingly enough, open source software on mainframes, which to me sounds like a blast from the past and a blast from the future.
My goodness, did we already do that? I seem to remember when I worked at IBM, getting some open source software of some kind onto some mainframe computer, and then that sounds like a solved problem. That sounds like a great show.
It should be a good, fun show, actually. Weaviate, which is open source knowledge graph. It's a GraphQL RESTful API-based knowledge graph, so that'll be fun. Practical Flutter. So we're going to have Hillel, who's been on the show, oh, man, it must be like 3 years ago. And I was also on his podcast, which is about Flutter. He's going to come on and talk about where the state of the world is with Flutter, which is really, really cool. It keeps moving forward all the time. Just added to the list, Hydra, which is a framework for elegantly configuring complex applications. Also just added to the list, Deep Code, which alerts you to critical vulnerabilities you need to solve in your code. So don't let security bugs go to production. Save time finding and fixing them. Also just added, by a lot of new ads here, XS Code, which turns your open source project into a steady revenue stream. How does that happen? I don't know. I have to wait for that show to find out how to do that, because I've written a lot of open source projects. And then Agones, or Agones, which is allows you to host, run, and scale dedicated game servers on Kubernetes. So this is actually a Google guy doing this. If you go to the big spreadsheet at twit.tv/floss, that's the homepage for this show. The link from there is to the upcoming lists. If you have other suggestions that aren't on that list, please tell the project leader or the community coordinator to email me. My email address is right there. We have a live stream at 9:30 a.m. Pacific time on Wednesdays. We take a number of questions from there every week. Sometimes the number is 0, but it's always a number of questions. Oh, I give up on that. You can follow us at Floss Weekly on Twitter. You can follow me at Merlin, Merlyn on Twitter. And also go to the twit.community site. We have our own forum area there, and I watch that like every other day to see if anybody's asking questions there. I have nothing to plug, actually, at this point. I'm not going to any upcoming conferences, and I'm just kind of staying home and staying in Santa Monica, and that's about it. So, Simon, anything you want to plug?
Well, I'm going to be at FOSDEM, which is the Free and Open Source Developers European meeting.
Right.
Me and something like 8,000 of my closest friends will be getting together at the Université Libre de Bruxelles. And we'll be talking about pretty much every free and open source project that you've ever heard of across. They've got something like 350 different sessions going on over 2 days, a Saturday and Sunday. And then all of these peripheral meetings starting as early as Wednesday the 29th and going on as far as February the 4th. So if you live anywhere in Europe or in a location that has a way of getting to Europe, you really should be at FOSDEM and going along to at least one of those things. If you're going to be there, drop me a line. Maybe there will be time for us to share a beverage. Probably not a beer because I've got to watch my weight, but certainly a coffee and maybe a lettuce leaf or two. Apart from that, very little else to plug. I am WebMink everywhere, and I'm delighted that GitHub approved my GitHub sponsors account. So you can sponsor me on GitHub if you like me being on the show here. And if you don't like GitHub, you can sponsor me on Patreon, and the other way around works as well. I think that's everything, Randal.
Simon, wonderful to have you on the show once again. It's been a while. You've been, as I said, when we sent the email, it's been a while since you've been at bat. So there you are. And I got to go. We're out of time. We'll see you all again next week on FLOSS Weekly.